All right, hyperbolas or hyperbolas. You say tomato, I say black eyed peas. However you want to say it, hyperbolas, hyperbolas. The definition, we're not going to give a fancy definition. We already did that for ellipses. And as we talked about during class, is that if you have a circle is an ellipse where the foci are at the center. But as you pull the foci out from the center, we talked about that's what makes an ellipse, right? As you pull, here's the center, as you pull the foci farther and farther out, the ellipse becomes, oh my gosh, that's the worst ellipse ever. The ellipse becomes wider and wider and smaller and smaller until eventually it would make a straight line, which isn't an ellipse at all, right? And if you pull it too far, eventually the center is going to be right here. The foci are going to be out here, but the curve is going to go and flip around and make what's called a hyperbola. This is a hyperbola right here. All right, so let's talk about the general equation. The general equation for a hyperbola is x minus h divided by r sub x, quantity squared, minus y minus k divided by r sub y, quantity squared, equals 1. That's the general equation. Or it could be the other way. It could be negative quantity x minus h. Oh, I forgot my squared. I'm sorry. On this one, get that squared. Divided by r sub x, quantity squared. Then this one would be plus y minus k divided by r sub y, quantity squared, equals 1. All right. Now, what's the difference here is where the negative is. Now, here's what's up. If the y term is negative, the x term, this mess here, is positive. What this is going to look like is, now here's the thing, there's going to be a box, and we'll talk about this box later. For right now, we got a box. There's going to be two diagonals through this box called asymptotes, and we'll talk about asymptotes later. We're going to draw this for each one. Each one is going to be a box, and then there's going to be diagonals called asymptotes through each box. All right, so here's what's up. If the x term is positive, the y term is negative, then that means the hyperbola is going to be on, it's going to open up the way the x's happen, left and right. Something like this. And if, in this case, if x is negative and y is positive, that means that it's going to open up and down, just like an x. Now, when I say hyperbolas, what this means is this line is going to skate along this green dashed line, but it's never going to cross it. The asymptote is kind of like a guide as to, oops, see, I crossed it there. It's not supposed to happen. It's supposed to, asymptote is kind of a guide of what this hyperbola is going to do. So when x is positive, left, right. When y is positive, up, up, down. Now, C, of course, is the center, and that's HK. And then we're going to talk about the foci. The foci are a little bit different than they were for ellipses. The foci, it's still C. C is still the focal, little c, right? This focal radius. But the way that that's going to be found is c squared equals r sub x squared plus r sub y squared. R sub x squared plus r sub y squared. Now here's the thing, y'all. It's actually the same thing as ellipses, except that instead of minus, it's plus. Remember, for ellipses, it was little c squared is equal to the semi-major squared minus the semi-minor squared. Now, we had to get all fancy with the semi-major and semi-minor because it mattered because we were subtracting. And if you had the little one minus the big one, you would get a negative number, and you would have c squared is equal to a negative number, and that can't happen. That's why it mattered. Here, because we're adding, it doesn't matter which one is little and which one is big. So that's why before we were all fussy about semi-major and semi-minor because it mattered, the order that we went in. This time, oops, since it's plus, it's r sub x and r sub y. All right, and then the last thing that we're going to talk about is asymptotes. Asymptotes. And we'll do asymptotes when we're doing this. But here's what's up. For a hyperbola, this is the information that I'm going to expect you to find. Let's do an example. I'm going to go to a brand new page. Let's do, there's a fun one. EX, 25x squared minus 9y squared minus 200x minus 36y plus 589 equals 0. Holy yikes. All right, so let's put this in graphing form. So just like always, get rid of the constant, separate the x's and y's. So I got 25x squared all right, so separated the x's and y's, got rid of the constant. Next thing is factor off the leading coefficient. Now with x's, in this case, it's pretty easy and straightforward, but be careful with the y's. All right, let's do this. So we got 25 times the quantity of x squared minus 8x. Leave a space. A negative 9 is going to come out of here. We want to have positive y squared inside there, so it's going to be y squared plus 4y. Leave a space is equal to negative 589. All right, just that's the trick. You got to watch out for your negatives. All right, let's go ahead and complete the square. Adding 16 here, but I'm going to add 400 to this side because 25 times 16. I'm going to add 4 here, but I'm actually going to subtract 36 from this side because of that negative 9. All right, and then we factor this. X minus 4 quantity squared minus 9 times y plus 2 quantity squared equals, what's this mess? This mess is actually negative 225. All right, now, just like ellipses, standard form is equal to 1. So we're going to divide by negative 225 on both sides. In fact, everything gets divided by negative 225. So what is 25 2/25? I'm going to look for this one. You're going to have x minus 4 quantity squared divided by negative 9. Negative 9 divided by negative 225 is positive y plus 2 quantity squared divided by positive 25 equals 1. All right, now, just like with ellipses, we're going to tuck up the bottom inside the parentheses. So you got x minus 4 divided by 3. Negative is outside. All right, just put this negative outside. Plus y plus 2 divided by 5 quantity squared equals 1. So there's our graphing form. There's our graphing form. So now that we've got this, let's talk about our center. Our center is the point 4, negative 2. R sub x is 3, and r sub y is 5. All right, let's graph this. And I'm going to make an ugly graph. So our center's at 4, negative 2. And R sub x is 3. Now, we're going to do this the same way that we did before. We're going to go 3 left and right, so 3 this way, 3 left and right. We're going to go 5 up and down. 2, 3, 4, 5. All right, but this time, rather than drawing an ellipse or a circle, we're going to draw a box. Now, your box, these 4 points that we just made are going to be the midpoints of the box. These 4 points are the midpoints of the box. Something like that. All right, and then we're going to draw diagonals through this box. Now, your diagonals should go through your center, because I'm the worst drawer ever. I kind of fudged mine. Oh my goodness. Don't worry, but for your notes, here you are. Okay, now, because y is positive, because our y terms are positive, that means that this is going to go and open up and down. This is what we're looking at when I'm talking about positive or negative. This negative and then the x mess, that means that, and then I got positive and then the y mess, I'm looking at this. This positive y mess, that means that this opens up. So at the midpoint of these boxes, of this box, these midpoints, that is going to be kind of like the vertex of this hyperbola. So, and then it's going to go up along the asymptotes and right along the asymptotes like that. All right, so there's the graph. Ugly as it is, there it is. Right? Okay, now let's talk about the foci. The foci. Now, if you recall, c squared equals r sub x squared, 3 squared, plus r sub y squared, 5 squared. So c squared equals 9 plus 25 is 34. So c is approximately, plus or minus, 5.83. Square root of 34 is 5.83. So where do our foci occur? Our foci occur 5.83 units from the center. All right, now it's 5.883 units up and down because our parabola is going open up and down. That's where our foci are going to be, up and down from the center. So our x-coordinate's not going to change in either case, right? Our x-coordinate's still going to be 4 in both cases. What happens, though, is we go up 5.83 units from negative 2. So negative 2 plus 5.83 is going to be 3.83. So it's going to be somewhere up here. Here's F1. F2 is negative 2 minus 5 is negative 7.83. So it's going to go down 5.883. It's going to be inside. Your foci should be inside each curve. Those are our two foci. That brings me to my crooked asymptotes. Now, the asymptotes are two lines. Even though mine don't look like it, they're straight lines. Right? Now, we're going to find the equation of these lines. And point slope form is fine. But if we're going to use point slope form, we need both a point and a slope. Now, both of these lines have a common point. What is the common point these lines have? They both have a common point at the center. They both have a point at the center for negative 2. That's our point. Now we got to find the slope. Well, here's the thing. we're at this point here. What is the slope of this positive line here? Well, how much did it go up? Well, r sub y is our up, right? And how much did it run? R sub x is how much it went to the side. Right? So this is positive r sub y divided by r sub x. What about this line here? What about the second asymptote? Well, from this point to get to this corner, r sub y still goes up, but then we have a negative r sub x. So it's negative r sub y divided by r sub x. So here's the thing: no matter what your asymptote is, it's always going to be your center, and then your slopes are going to be plus or minus r sub y divided by r sub x in every case. All right. So our two asymptotes here, one is at y plus 2 equals, this is point slope form, y plus 2 equals positive. Oh, yeah, we never said what our slope was. So in this case, it's going to be plus or minus r sub y 5 divided by 3. Because r sub x and r sub y were right here. So y plus 2 is equal to 5/3 times the quantity of x minus 4. That's one of our equations of our asymptotes. The other one is y plus 2 equals negative 5/3 x minus 4. So here's the thing. Your asymptotes, C is your point. Your slope is always going to be r sub y divided by r sub x. So both equations are going to be similar, just one's going to have a positive slope, another one's going to have a negative slope. All right. Do one more example for good measure. Our example is going to be x squared minus y squared plus 4x plus 16y minus 69 equals 0. Tell you what, you could go and, complete the squares and put this in general form. If you want to, go ahead and press pause and do that. I'm going to save us a little bit of work and tell you that x plus 2 divided by 3 quantity squared minus y minus 8 divided by 3 quantity squared equals 1. This is what the graphing form of this particular problem is going to be. All right, so the center is at negative 2, 8. R sub x is 3, and r sub y is 3. Now, when I graph this time, I'm going to use a graph. While I'm finding my graph, you guys can start drawing yours or whatever you need to do. But here's what's up. So we got negative 2, 8. I go 3 up, 3 in all directions, it turns out. That kind of reminds you of a circle, right? Oops. But this is not a circle. Remember, these are midpoints. Draw your asymptotes. Now, this is not a circle because we have a negative term in front of the y, or it's minus the y mess. And because it's minus the y mess, that makes this a hyperbola. So, and because the x term is positive, that means that this particular graph is going to open left and right. So, from the midpoint of the box, it goes like this and this way. From the midpoint, the other midpoint, it rides along the asymptotes. Never crosses it, but rides it. All right, so there's our graph of our hyperbola. Let's find the foci. Remember, the foci, c squared equals 3 squared plus r sub x squared plus r sub y squared. C squared is equal to 18, so C is approximately plus or minus 4.24. Those are our, that's our focal radius. So where are our foci? F1 and F2. Now, because the foci are going to be inside these curves, our foci are going to go left and right from the center. From the center. So our y-coordinate doesn't change. Because we're moving left and right, this is going to stay 8 and 8. But our x-coordinate is going to change. -2 plus the focal radius of 2.24 is -6.24. And then -2 minus 4.24 is... Oops, I did that backwards, but yeah, either way, it doesn't matter. We should get -6.24 and 2.24. So, plot these 2 points. This is F2, -6.24. This is F1. So those are our 2 foci. Then that leaves us the asymptotes. The asymptotes. Remember, we're using the center, -2, 8. And our slope is going to be plus or minus r sub y divided by r sub x. So 3 divided by 3 is plus or minus 1. So our 2 equations are going to be y minus 8 equals 1 x plus 2. And our other one is going to be at y minus 8 equals -1 x plus 2. So, that's hyperbolas or hyperbolas. Smith out!